Physical Science, this is Mr. B, and this video is going to kick off a new chapter for us, and it is chapter 3, and it is titled States of Matter. So if you remember, our last chapter was called Classifying Matter, and in that chapter we learned basically the different types of matter that we had. And then now for this chapter, we're going to get into actually the different states, or kind of maybe an easier way to remember would be the different forms in which matter exists, because we kind of alluded to this earlier, that there are three types called solids, liquids, and gases as our main states of matter, and that is actually a nice little segue into the title of this section, which is in fact solids, liquids, and gases. So we're just going to take a look at basically getting a little introduction about the basics about what each one of these is in this video. But before we do that, again, we have to start off with our little example, as they always do here. And our example to introduce us to this chapter starts off by saying that carpenters use a level to find out if a surface is perfectly horizontal. When a carpenter places the level on a surface that is perfectly horizontal, the air bubble stays in the middle of the horizontal tube, as you can see there on the right. The metal, alcohol, and air in the level represent three different states of matter. So again, we have our little bubble right here. The air is gas, the alcohol is liquid, that's what it is, the bubble is floating in there, and then the metal is our solid. And so we're going to ask ourselves one big question before we start here when we talk about the states of matter, and that is, how can shape and volume be used to classify materials? As you're going to see as we go through this video, there's going to be a definite theme and a definite pattern that's going to develop. Basically, we classify materials based off of their shape, basically kind of what form they take, and their volume and how much space they take up. So materials can be classified as solids, liquids, or gas based on whether their shapes and volumes are definite, meaning that they're constant, they stay at one thing, or they're variable, meaning that they can change. So these two indications right here, I would definitely write these down. Shape and volume are two big characteristics that we're going to look at when we determine whether something is a solid, liquid, or gas. So our first one we're going to take a look at is solids, and they just start by saying, what do these four objects have in common? Again, they tell us a pencil, a quarter, a book, and a cafeteria tray, and that is they all have a recognizable shape. Again, each one of these has their own unique shape, and they all take up a certain amount of space. So again, a pencil is going to take up more space than a quarter. Cafeteria tray is definitely bigger, going to take up more space than our pencil and our quarter. And the book, again, could be kind of variable. It's kind of random. But again, we can have a definite picture in our mind when we think about all of these things. And that's because they all take up a certain amount of space, and they're very recognizable. So the materials in these objects are all in the solid state. And when we define the solid state, it is the state of matter in which materials have a definite shape and a definite volume. So I would definitely write that down. And again, solid, they have a definite shape and a definite volume. So there's not a lot of change going on when something is in the solid state. So samples of solid copper have a definite volume, and that's because the atoms are packed close together in an orderly arrangement. So when we take a look, again, if we break things down to the atomic level, when we talk about a solid, all of the atoms are going to be really close together. So that's one way, our big indication that tells us that something is a solid. And almost all solids have some type of orderly arrangement of particles at the atomic level. So almost every single solid that we look at is very closely packed together. It's very orderly when we look at it. Again, at the level of atoms, we call that the atomic level. So that is a solid. It has a definite shape, definite volume, orderly arrangement at the atomic level. And then a liquid, and again, this one just kind of talks about, again, they always give us a little example. It says, how good are you at estimating whether the juice remaining in an almost empty bottle will fit in a glass? And a good way could be because the shape of the liquid changes as you move it from one container to another. So that might make it a little more difficult to tell if maybe it's going to fit in the glass that you have, because again, it'll take the form of whatever it is. So a liquid, a characteristic of a liquid is it always has the same shape as the container that it's in. So that's a big thing for a liquid, and it can be poured from one container to another. So, but to get our official definition of a liquid, so this is the one I would write down right here, is that a liquid is a state of matter in which a material has a definite volume, so it's always taking up the exact same amount of space. However, it does not have a definite shape. So we could have, again, something that fits into a completely regular size glass, and again like a normal drinking glass that you think of, and then we can maybe pour it in to a really flat pan or something like that. So in one state it's going to be kind of maybe stacked up more on top of each other, and then that's one shape that it'll have. But if you pour it into maybe something that's not quite as tall, it's going to fill out that entire surface and have a different shape. However, the volume is not changing, so how much there is not changing, but the shape that it takes is changing. So that is a definition of a liquid. So it's similar to a solid in the fact that it has a definite volume, but it is different from a solid that it does not have a definite shape. So that is kind of the big indication of a liquid. And again, our example that they're going to give us is at room temperature, mercury is a liquid, and drops of mercury on a flat, clean surface have a round shape, as you can see over here on the picture on the right. So this is what mercury looks like in the liquid state. So again, if we just poured it out onto a flat surface, this is what it looked like. However, if we would take this same mercury and pour it in a container, it would have the same shape as its container. So the atoms are close together, so we'll get a little, I think they're maybe on the next slide. Yeah, there you go. So again, the atoms are really close together, but their arrangement is more random than the arrangement of atoms in a solid copper. So again, the atoms are still pretty close together, however, they're at a little more random arrangement, and that's what kind of allows the liquid to take the shape of whatever container it's in. It's because its atoms are a little more random than what we find inside of a solid. So those are our first two states. We have a solid and a liquid. Hopefully you remember that our last one is going to be a gas. So gases, they just say, again, if you were asked to name a gas, what would you say? Maybe something that kind of comes into everyone's mind right away is air, because again, that's probably the most obvious example, because we breathe it in every day. And air is not just one particular gas, it's a mixture of many gases. And our definition for gas that you need to write down is that it's the state of matter in which a material has neither a definite shape nor a definite volume. So it's similar to a liquid in that it does not have a definite volume, but it's different from a liquid that it does not have a definite shape either. So a gas will take the shape and the volume of its container. So no matter what you put a gas in, it's going to take the shape of it, similar to a liquid like we said, but its volume will vary depending on what you put it in. So for our example over here is we have some balloons. So the balloons are filled with helium, which is a colorless gas that is less dense than air. So if you've ever seen balloons that are floating up in the air, that is because they are in fact filled with helium. And again, we learned last chapter that density kind of determines, again, the ratio of mass to volume. So it's less dense in the air, so it will float. And then two of the balloons are teardrop shape, as you can see, the green and the I believe that's an orange one over there. And then the shape of the helium, and then two are disc shape, as you can see, the gold and the pink one. And the shape of the helium in the balloon is the same as the shape of the balloon itself. So the helium atoms inside that balloon have arranged themselves to be the exact same shape as the balloon itself, and we can see right there. So again, the atoms, again, before we put them in there, they were the exact same as the container. I think it's okay, yeah. I think we'll get to that in a second. But basically, before these helium atoms were inside of this balloon, they were in the shape of their cylindrical container. Then when they get put into the balloon, now the helium atoms have arranged themselves into the shape of the balloon. They're going to take on whatever type of container that you put them in. Okay, so again, this is where we're gonna, I think I hinted on this a little bit, but the helium atoms in a balloon are not arranged in a regular pattern. Sorry, I can't talk here. They are at a random locations throughout the balloon. So again, gas, their solids are really orderly. Liquids are a little more random than solid, and gases are basically completely random because they'll fill up whatever you put them in. It said because of the space among helium atoms, a large amount of helium can be compressed into a metal cylinder, kind of what I said. And when helium flows from the cylinder into a balloon, the helium atoms will spread out, and the helium can fill balloons with much more volume than the cylinder. So that's kind of something that's a little bit interesting as well. So again, it doesn't even necessarily have to have as much helium to fill up. Again, we can use one little tiny cylinder because again, the helium will pack really tight in there, and then we could fill up multiple balloons that take up a lot more space in that cylinder because they will take on the shape of whatever they're in and the volume of whatever they're in as well. So to wrap this one up, we're going to talk about some other states of matter. We're not going to spend too much time on them because They don't really present themselves here on Earth that much. So about 99% of all the matter in the universe exists in a state that is not as common on Earth as solids, liquids, and gases. At extremely high temperatures, such as those found in stars, matter exists at a state known as plasma. So that is a kind of a state that exists kind of outside the realm again of Earth and stars. And at temperatures near negative 273 degrees Celsius, groups of atoms behave as though they are a single particle, and this fifth state of matter is called the Bose-Einstein condensate, or the BEC. And again, we're not going to spend too much time with those, maybe just be familiar with them as we go forward here. So that's it for the first part of section 1. Let me know if you have any questions.